here are the main objects we will be dealing with in this chapter. Again, we made some visual aids with the tetrahedrons, which actually fall into the pyramid family. It's a triangular pyramid because it's a triangle on the bottom. So this one here, is this one that you see on the top right here, is that a triangular pyramid? No. So what kind of pyramid is that? Well, what's the bottom? It's a pentagon, so it's a pentagonal pyramid. Excuse me. This one here is a pentagonal prism, because if I were to tip this down, the pentagon would be on the bottom and on the top, correct? So basically this one has how many bases? Top, bottom? 2, right? That one only has 1. Big difference. Here, this one has a circle on the top and a circle on the bottom, so it has 2. This one only has 1. That one, the sphere, obviously has no bases whatsoever. What we will do with these is we will find surface area. What is the area of all those faces that you see? And we will also find volume. Those will be the things we'll be working with in this chapter. Again, volume, how much of something can you fit inside? So right here I have a picture that is somewhat on yours. Mine has been changed slightly. But we have things that are called edges, things that are called faces, and things that are called vertices. You may notice I have something a little different from my usual over there. That's because this is about when I got my smartboard for the first time, and I was just playing around with some of the stuff that was on there, and I just haven't changed it since then. So edges are basically any segments that are in your particular object. And so I would consider that this is a pyramid. I would say it's a rectangular pyramid, and it has a lot of edges. For example, do you believe that ED would be considered an edge if it's one of the segments? Yeah. And also EC, EB. Does EA count as one of the edges? Even though we can't see it, it still counts? Yeah. Okay, it's just right in the back there. How about the ones on the bottom? Do they count as edges? Yes. The one at the bottom, though, those are going to be called base edges because that's the base. These will be called, so these are base edges down here. These ones down at the bottom, and maybe we'll color code them and put them in green because they're on the base. Once again, very clever how they name some of this stuff. This might be a little bit harder. These are called lateral edges, the ones that kind of go up. All right. And so for edges, here we go. And notice I have a segment over the top of those. For example, for this first one, could you have put CE instead of EC? Sure. Do they have to be in the order I put them? No. All right. So basically what I did, it looks like I put the base edges towards the end. The last 4 are the base edges, the first 4 were the lateral edges. It doesn't matter, it's just the way that I happen to organize it. Okay, so make sure you get those down. Again, any order is just fine. So whenever I use the word edge, that's what you should be thinking of. Or you can look at these that we have in the class, that they have several edges as well, just not labeled. Okay. Faces, I briefly used that word the other day. In fact, I think one of you kind of came up with the word first. Faces are basically all of these flat surfaces. Okay. Does this one have some faces? Yes. In fact, how many triangular faces does this particular object we have here, how many triangular faces does it have? 4, and then what's the other face? The best we can say is, we hope it's probably a square, but it could be a rectangle, right? But again, it is called the base. Okay, so that's kind of how I would do it. Say we got triangle EBC, okay, which would kind of be this one almost kind of in the front for you, right, is EBC. We have triangle EDC, also kind of in the front. AED is kind of around the corner, and so is EAB is around the corner. And as you already told me, ABCD is the base. Once again, in all of those, you can pretty much put those letters in any order you want because we're not talking congruence. We're just getting them written down. So pretty straightforward. So this particular pyramid has 5 faces total, correct? How many faces does this one have that we made? 4? Okay. So pyramids can kind of have any number of faces, odd or even. And vertices, I think that's probably the easiest one. We saved it for last. Basically, it's just the letters, the points. And notice this time I did not put them in order, just to kind of see. So for this pyramid, any idea what they might call E for this particular one? think I heard it. The vertex, yeah. Because it's up there all by itself. So any questions? Pretty straightforward, right? We've done a lot of this stuff already. And the fact that you're all really tired probably doesn't help much. You're also energetic. This is, again, something I was just playing with because I just got the smart board, and it's kind of fun. And I think you noticed I've gone away from this particular setup, and you're probably happy about that because this looks kind of weird. But polyhedron is on the back for you. It is already written in. Polyhedron, a solid with all flat faces. So does this object that we made right here, does this get considered a polyhedron? Are all the surfaces flat? Yes. How about the pyramid we had in the last example? Does that count as a polyhedron? Yeah. How about that octahedron that's back there? Does that count as a polyhedron? Yeah, that's the only one in the classroom, but yeah, that's the one. How about the cylinder? Are they flat? Interesting question. We'll have to decide that as we go. So what's the next one on there? A prism. What did you notice about the prism picture that was back here? The pyramid had one base. The prism has two. And are all the surfaces flat for that? Yeah. So here's how I would do it. I'd say, okay, I know that it's a polyhedron, which means it has flat surfaces. See how I kind of cheated there, so I didn't have to write so much? With two congruent faces called bases. And that even kind of rhymes at the end. And those bases could be, could be a square, they could be a pentagon, could be a triangle. And what most people struggle with in this chapter is just drawing some of these things, which is what the next section's all about, trying to get you so you can draw some of this stuff. What's the next one for you? Pyramid. What are some distinguishing features of a pyramid then? One base comes to a point, and all the other faces come. Wow, that's perfect. All the other faces come to a point. So it's a polyhedron though, right? Because that means a solid with flat faces. Wow, so that's about the third time I've come back to that, so maybe that's important. That has all faces except the one intersecting at a point. Or you could go, like Dakota said, hey, there's a base, and all the other faces hit at a point. That's good, right? It's the same thing. In its own words, and it might help you. So what do you think? What's the next one for you? Cylinder, what do you got there? I almost always start with the number of bases. Cylinder has two, and can we talk about the bases a little bit more specific? Circular, yeah. And it's definitely not, what? Not a polyhedron. There you go. Look at how good you are at making definitions. Let's face it, we've been working on that. Circular bases are congruent and not a polyhedron. You might want to put two circular bases because you told me that already. So we're doing quite well. So any questions on the four that we have so far? No? What's next? Ooh, regular. Polyhedron. Well, we've done regular polygon, right? Regular polygon meant that all the sides and all the angles were congruent. So what do you think it means for a regular polyhedron? All faces are, yeah. Whoop, got to hit the number one. A polyhedron with all faces being congruent regular polygons. All faces. So that's probably the number one example of that. A polyhedron with all faces being congruent regular polygons. Yes. Yeah, cube's probably the easiest one to come up with, right? And number two maybe the tetrahedrons we made. They are all regular polygons on the faces, right? So are there many regular polyhedrons? Not a whole lot of them. Because does that octahedron count back there as a polyhedron with all faces being congruent regular polygons? Yeah, they're all equilateral triangles. So they kind of have to be made up that way. So you have to be very picky as to what that looks like. And we only have two left, a slice and cross-section. And once we get done with slice and cross-section, I do have some websites I've found throughout the years that have been helpful in understanding a slice and a cross-section. And for the recording, I'll just show the websites, and then those listening can just go to those websites. A slice, planes that intersect a solid. I will borrow somebody's tetrahedron back here. And give you my viewing of that. We'll check time first. We're pretty good. But I think we'll do cross-section first, and then I'll show you slice right here. A cross-section is basically a slice that's parallel to the base or bases. And then I'll show the websites, and then we can stop the recording. And anybody that wants the visuals that we're going to do in class, you'll just have to stop in if you are listening. Everybody good? All right, let's stop this. Well, that was interesting. Let's stop this.